This is the 2018-2019 Pre-Calculus Fall Common Assessment first free response question. This is a calculator active question, and you had 15 minutes on this question. So in part A, you are asked to determine the value of R of 120. Since this is a calculator active question, I'm going to go ahead and start this problem off by putting the function R of t into my calculator directly. So let's go ahead and do that. I'm going to start by just adding a calculator, and I'm going to program in, I'm going to tell my function R of t, and I'm going to define that to be equal to, so let's see, define that to be equal to, colon equals, the function, so let's get a piecewise function here, 10 times t over 100 to the third power times 1 minus t over 300, and that is for 0 equal to t less than or equal to 300, and likewise 0 for t greater than 300. So now I've just programmed in what R of t actually is. Let me find out R of 120, and it tells me, oh, but I kind of want that, how about as a decimal value, so control enter, and it gives me 10.368. So let me record that down. R of 120 is equal to 10.368. And let's come back and finish the problem that says using correct units explain the meaning of your answer. Okay, so the 120 right here is my domain value, and if I'm looking in here, I see, let's see, R of t, this is the range, is measured in people per second, and then t is the domain, is measured in seconds. Okay, so since the 120 is the domain value, that's talking about the seconds right there. So let's see, when t equals 120 seconds, okay, what's happening then? All right, well, the function R of t is talking about people entering a line, but not just the people entering the line, it's talking about the rate that people are entering the line. So let's say that people enter the line at a rate of 10.368, and we got to get our units correct. Well, what's the units of R of t? Because there's just a value of R of t. It's measured in people per second, so people per sec. Okay, and this problem would have been worth 2 points. You would have gotten 1 point for getting the correct value right there and 1 point for getting the correct sentence. In order to get the sentence, you're definitely going to need to mention the t equals 120. You're going to need to mention what it is that's actually going on here. People are entering the line, and you've got to mention that word at a rate. It's not just how many people have entered the line, it's the rate at which people have entered the line. And then you've got to get the units correct as well right there, the people per second. Also, that 10.368 needs to match up with whatever your value was over here. So even if you didn't get this first value, if you had something else for R of 120, then if that number appeared right here and you had everything else correct, you still could have gotten this second point even without the first point possibly. So this was 2 points total for that first one right there. Okay, going on, at what time are people entering the line for the escalator the fastest? Well, the fastest would mean the rate is the greatest. This is the rate right here. R of t is the rate that's going on. So when is the rate the greatest? Well, it's the greatest right about here, and I'm not exactly sure where that falls. It looks somewhere between like 200 and 250. I don't know. Let's use the calculator though and find out the exact value of that. So if I come over and now I add a new page, I'm going to add a graph, and I want to define f1 of x to be R of x, And, oh, I don't see anything right here. Well, that's because I'm only going from 0 to 10, and if we remember back at the picture that they gave us, we go all the way from 0 to like 300, and from 0 up to, oh, I don't know, like 30 or so. So let's get our window looking good. Menu, window settings. We want to go from like 0 all the way out to, oh, let's go a little bit past 300, maybe 350, and then let's go from a Wyman of 0 all the way up to a max, oh, I don't know, maybe about 40 or so. Hopefully that looks good. Yeah, that looks really good. Okay, great. And the question was, when are the people entering it the fastest? That means we need to find the maximum. So menu, analyze graph for our maximum, and there it is. Looks like it's right at 225 is the X value. That's the number I care about because that's the time when people are entering it the fastest. The domain value is the time value. Okay, so then I'm going to come back over here and write when t equals 225. Okay, and that was very simply just 1 point. Didn't need any units or anything, just you got it or you did not get the 225 right there. Part C asks, what time interval does the function satisfy the inequality r of t is less than 25? Okay, so less than 25, if I look up at my graph right here, I see it's coming up, and it hits 25 at some point over here, and then it's above 25, but then somewhere over here it's going to get back below 25. So, okay, I got to figure out when, for what time periods are we below that 25. So up until I hit 25, and then after I hit 25 over to the end. So let's go ahead and get on our calculator and figure that out. If I do another line here at the height of 25, I can find our intersection points. So analyze my graph for the intersection point. There's one of them, and get the other one, analyze graph for an intersection point. Here's my other one. So let's get those two x values written down. It was when t equals 189.119 and when t equals 254.503. Okay, that's when our function hit the value of 25. But I don't just want those t values, right? It says over what time interval. So I want an interval. Does this function satisfy the inequality it's less than 25? That was when it was equal to 25. So I want when is r of t less than 25, well, it would be all the times up until right here, and then all the times after my 254. So all of these times up until then, and then all of the times after as well. So let me get that in proper interval notation then. It's going to be all the times from, and should I include the 0? Let's think. Well, 0 is allowed in my r of t, so yes, I should include the 0. I'm going to start at 0, go all the way up until I hit the 189.119, and then I'm going to union with the 254.503, and I'm going to keep going all the way on until, well, I could stop at 300, but it really keeps going past 300 and goes all the way on to infinity right here. So this was actually going to be worth 2 points. 1 point for just did you get the values that were going to be used as like the endpoints, and then the other one, did you actually get the intervals correct right there? Okay, so if you had the values, you got the 189.119 and the 254.503, but you didn't get the right interval notation, then you're only going to get 1 point on this. We did accept a 300 here instead of an infinity, although really the infinity is the better answer on this question. But if you put 300 right there, you would have gotten the credit on this. And if you had actually included these endpoints, we don't really want to include those endpoints. We really want it to be the soft parentheses right here, not the hard braces, because we're asking for strictly less than 25. And if it's actually equal to 25 at that point, we don't want to include that. So that would have cost you a point as well. Okay, going on to part D then. Part D asks us about the average rate of change of r of t on the interval from 250 to 280. Okay, and I've got to show my work. If I do not show my work, I'm going to be sunk. I'm going to be losing points big time on this problem. So showing my work involves showing the difference quotient. That means I'm looking for R of 280 minus R of 250 all over 280 minus 250. And I'm going to get out my calculator to figure out what that actually is. And the beauty of having R of t programmed in here is I can literally just ask it, what is R of 280 minus R of 250 all over 280 minus 250, hit enter, and it gives me, oh, again, I'd rather get it in that form. So approximately negative 0.380, got it written down, okay. And that would earn me my first point right here for getting the correct value with supporting work, in other words, the difference quotient. Okay, so you have to show the difference quotient. If you don't show me this work right here, then you are not going to get this point. And how do I get that point? Do I have to show it with the R of 280 minus R of 250? Well, you have to show me something that is a number minus a number over 280 minus 250, essentially. And if you had plugged in and figured out what R of 280 was, and you got that correct to 3 decimal places, and then you subtracted off R of 250, and you had that correct to 3 decimal places, then you could have gotten this without actually having it written exactly like I have written it right here. But you have to be getting across this idea and showing this work, actually, to earn this first point. Okay, just a bare answer right here does not earn the first point. Must show the work. Second point comes from giving me a good looking sentence, and the sentence is a little bit tricky to write. Here is what it is going to be. Okay, so from, where do I start? T equals 250 to T equals, where do I end? 280. What are my units of the domain? They are seconds. Okay, what is it that's actually changing here? Well, it was the rate that people enter the line. Remember, it was a rate that people that were entering the line. It was the rate that people enter the line that we're talking about here. If you just said the number of people that enter the line, then you are not going to get the point on this question. It's very tricky. The rate that people enter the line. Okay, what's going on? Is it increasing or decreasing? Well, this was a negative number, so decreases at a rate of, all right, I'm going to take the negative away because I've already told you it's decreasing, so 0.380. What are the units going to be? Remember, what are my units of the domain and the range? The range has units of people per second. The domain is seconds. So my units are always the units of the range per units of the domain. Remember, it's always a change in y. A slope is a change in y over change in x. The range is the y. The domain is the x. So we want the y units over the x units. That means people per second over seconds. In other words, people per second per second. It sounds weird, but that's it. People per second per second. I know it sounds weird, but that is what we are looking for. And that is our second point. 2 points total on that problem. One for the value with work, showing you the correct work. The other one for the entire beautifully written justification right here. You must state everything in here. You've got to say when we are going from and to. Oh, and I kind of made a little bit of a mistake. I really want to say at an average. Sorry about that. At an average rate, okay? So you got to say the from domain value 1 to domain value 2. You got to tell me what it is that's changing. It's the rate that people enter the line. You got to tell me if it's increasing or decreasing. And then you got to say what's this value right here with the correct units. You want to say what is it that's actually changing? Well, it's the average rate of this value is the same value as up here. And then our units are as units of the domain per units. I'm sorry, units of the range per units of the domain. Right there. Okay? Cool. 2 points on that one. Really tricky second point to get, but it is going to appear every single year on the Common Assessment. You're going to have one question like that. All right, last one, wrap it up with another tricky one. So in this one, we're given an equation right here, s equals a times 2 to the kt minus 1, and we're also told a and k are constants. So the only things that are not constant in here, notice, are s and t. So s and t are the only things that are not constants. Those are the things that I'm going to be playing around with a whole bunch in this. All right. So we want to rewrite the equation as a function of s. And I think most students last year when they saw this were just confused, did not understand what this problem was asking, and did not know how to start this problem. And to be honest, it is tricky to understand what this is asking. So let's break it down a little bit. A function of s. What does that mean? Well, usually you say something like, we're going to write y as a function of x. Y equals f of x is a function of x. What does that mean? Well, notice, where is the x? X is the domain value. X is the domain value. Okay, so if y equals f of x, that means that we've got a function of x. X is the domain value. X is the thing that's going on the inside. So we want, as a function of s, that means we want s is the domain value. Okay, well, what do we have right now? Right now we have something like s equals. Well, that's not what we want. Y equals f of x. F of x is the domain value. We want the domain value to be the thing that's on the inside, not the thing that's equal to. So in other words, we want to flip-flop the s and the t. We want t to be equal to something in terms of s, not s to be equal to something in terms of t. So let's see what we can do. Okay? So we've got s equals a times 2 to the kt minus 1. All right, I'm going to start breaking this down. I need to isolate the t. I want to get t equals. So let's go ahead and divide the a over, and I'd have s over a equals 2 to the kt minus 1. Don't like the 1 on there. I'm going to add it over. I'd have s over a plus 1 equals 2 to the kt. And there are two different things that I'm thinking about doing at this point. All right, I'm going to break it down with a little method 1, method 2. So over here, I'm going to talk about method 1. All right, if I'm doing method 1, what I'm thinking about is I'm going to take a log base 2 on both sides of this equation. And the reason I'm doing a log base 2 is I've got 2 to the stuff. Well, log base 2 of 2 to the stuff is just going to be the stuff that's up in the exponent. Okay, so if I do a log base 2 on both sides, what I end up with is log base 2 of the whole left-hand side, s over a plus 1, would be equal to log base 2 of the whole right-hand side. Well, log base 2 of 2 to the stuff is just the stuff, so it's just the kt. Hey, and I wanted to isolate, remember, k is a constant, so I want to isolate the t. What am I going to do? I'm going to divide over the k, so I'd have log base 2 of s over a plus 1 all over k is equal to t, and that would be an answer that would earn me full credit. Method 2 is pretty similar, but in method 2, instead of taking a log base 2 on both sides and just canceling out the 2 to the on the right-hand side, what we're going to do is instead we're going to take a log of any other base. In fact, why don't we choose the natural log? That's kind of the most natural one to choose. If we do an ln on both sides, let's see what happens. So if we do ln on the left, we have ln of s over a plus 1, and on the right we would have ln of 2 to the kt. Okay. On the right-hand side, I'm going to be able to pull down the kt. On the left-hand side, I'm not going to change anything. We just have ln of s over a plus 1. So I said I'm pulling down the kt, ln of 2. That's my power rule. I can pull down a power inside of a logarithm. So last, I wanted to isolate the t. Well, there's a k on it, and there's a ln of 2. Why don't I divide by k times ln of 2, and I'd end up with ln of s over a plus 1 over k ln of 2 equals t box that answer in, and I would be earning full credit for this answer as well. Doesn't matter which one of these answers I give. In fact, if I chose any log, it doesn't have to be ln, it could be log base 10, it could be log base 10, as long as these logs have the same base, log base 10, log base 10, log base 100, log base 100, as long as they're the same base, then this answer is valid and would earn full credit, okay? It's just most common that we would either use the ln or we would have used the base 2. So these were the most common answers, but you could have given me log base 100 and log base 100 right here, as long as they aligned. And the way that points were awarded on this one, it was 1 point for correct use of a log to pull down the exponent on the 2 to the kt, and then another point for all other algebra. So if you had all the other algebra looking good, then you got your other point for 2 points total on that problem. Awesome. I hope this was helpful to you guys. Have a good day.